Is Monday, or I guess for you guys it's Tuesday, and I'm going to teach you a little bit about what's called an imaginary number today. I was really hoping I would be there when we had to learn this, but we must move forward and I'm not going to be there. But this is one of my absolute favorite topics in math. We'll do a lot of it in the next week or two. And so today we're going to cover essentially what is I. So I is an imaginary number. We're going to talk about what that is. We're going to talk about powers of I. So I squared, I cubed, I to the fourth. And we're also going to talk about radicals or square roots of I. So what's the square root of this weird thing we're calling I? So I've got kind of three sections here. We're going to talk about motivation for why the heck we're talking about imaginary numbers. We're going to define them. And then below, we're going to do some examples. So the motivation is this. We know that the square root of 9, or a positive number, they have square roots, but the square root of 9 is equal to 3. So the question is, what is the square root of -9? And we should know that the square root can't be 3 or -3 because 3 squared equals 9. So 3 squared does not equal -9, but you can't square -3 to get -9 either. -3 times -3 makes a +9. So really, 3 and -3, if you square them, are not going to give us this -9. And so up until today, we would have said that the square root of -9 is undefined. We would have said we haven't defined it, we don't know, but the two numbers we would use, 3 or -3, neither of them work. So what happened essentially is that mathematicians straight up invented a new kind of number. I use the word invented because they defined something new. Some people would argue that it was found out in the universe and we just, gave it a name. But I'm going to use invented or defined. And we're calling these things imaginary numbers. So imaginary because essentially we can't see them. We don't have a physical representation, right? If you wanted to know what 3 was, I could draw you the number 3. Here we go. There are 3 things. But if you wanted to draw an imaginary number, you're going to get into a little bit of a bind. So we'll talk about a lot more of how we represent them and what they look like. But today, we just need to know kind of what they are. So mathematicians invented imaginary numbers to help solve problems like what is the square root of -9? What is an imaginary number? An imaginary number is I. So this symbol here, it's kind of like a cursive tilty I. We call this an imaginary number. It's an example of an imaginary number. It's the most basic. It's called the imaginary root in some people's minds. And the definition is this. They defined I such that if you take I and you square it, so I times itself, you get -1. Now, up until now, this was not possible. We could not square a number and get a positive or get a negative number. We always got a positive number. So I is some weird new thing. It is not a number that we can conceive of, really. But when you take I and multiply it by itself, you get -1. This is the main definition, and we're going to spend a lot of time with this. Now, if I were to extend this definition, I can also say then that the square root of -1 is equal to I. So both of these are going to be really fundamental for us to remember. So wherever you're doing right now, take this, write this down on your paper or write it down on a scrap piece of paper so you can see it. I squared equals -1, which means that the square root of 1 is equal to this weird number I. All right, let's see some examples of how to work with this because it's a little strange. I'll try to leave it on the screen so you can see it too. So 2 different things we're going to look at. The first is working with imaginary roots or imaginary radicals. So what happens when we're taking square roots that involve imaginary numbers. And then we're going to talk about powers or exponents with I, powers of that imaginary number. So our first question here is, what's the square root of -25? And now like before we had imaginary numbers, we couldn't solve this problem. We would have said undefined. But now we have this rule that we have a way to find the square root of -1. So I'm going to split the square root of 25, just like I did yesterday, into 2 pieces. I'm going to split it into the square root of -1 times the square root of 25. And now, just like I did yesterday with my roots, I'm going to solve each one individually. What's the square root of -1? Well, that we are calling I. And what's the square root of 25? We know that to be +5. So I have just simplified my square root, which I've never been able to do before, and I have found that the square root of -25 is 5i. So we always write it where the coefficient comes first and I comes second, just so you can see that. So 5i. Let's do another example. The square root of -12. So just like yesterday, I'm going to split this into pieces. We're first going to take that -1 out. And then I'm going to do what we did yesterday and say, okay, what's the biggest perfect square that divides 12? I think that's 4. And 4 times 3 gets me 12. And -1 times 4 times 3 does equal -12. And now I'm going to simplify. The square root of I, or square root of -1 becomes I. The square root of 4 becomes 2. And the square root of 3 cannot be simplified. And if I want to write this in the correct order, I'm going to write this as 2i. So again, my coefficient comes first, and my square root or my radical comes last. So 2i times the square root of 3. That is the square root of -12. So today you're going to get some practice doing simple roots like this, separating out that -1, and just getting used to seeing I in these answers. It's a little weird at first because I is this weird number we don't know, but I just want you to get familiar with how you write them and how you pull that root -1 out of your problems. The other thing you're going to see is we can also work with I and do things like square it, or take it to the 5th power, or take it to the 8th power, things like that. So here we've got I to the 5th power. And we don't have to know how to think about I or how to picture I in our heads in order to solve this problem. We can just use our definition that we know what I squared is, right? So we know that I squared equals -1. So I'm actually going to split this into as many I squareds as I can. I to the 5th is I squared times I squared. That gets me I to the 4th, so I'm almost there. I just need one more I. To the 1, we'll say. I squared, I1. 2 plus 2 plus 1 equals 5. And now I can simplify this to, well, I know that I squared equals -1. I know that this I squared also equals -1 from my rule. And then I have one I left over. Negative times negative makes it positive. And so this simplifies to 1i, or I can just write it as I. So if I want to simplify my powers, I just need to pull out as many I squareds as I can and use this rule that I squared equals -1. You're always going to get positive I or negative I or positive 1 or -1. It's pretty collapsed what the options are. But we can also do things like include numbers here. So this is 5i. Quantity to the cubed to the 3rd power. And I can think about this as 5 cubed times I cubed. Now, 5 cubed, I distributed that exponent, is 125. And I want to split I cubed again into powers of I2, or groups of I squared. So I cubed is just I squared times I to the 1. So my answer here is 125 times, we know that I squared is -1 times I, and I can simplify this to -125 I. Woohoo! All right, weird. So this is what we're working on today. These 4 examples are going to get you through everything you need to get through. The main ideas I want you to think about are, when you're working with roots, make sure you pull out that -1 so you can deal with positive square roots. And with powers, your main goal is going to be to pull out those I squareds because you know what those equal from our definition, and work with those to simplify. All right, guys, good luck. Text me if you have any questions, and I'll see you later. Bye.